We're in the middle of the construction of a new sewage lift station outside of San Antonio, Texas, that will eventually help the wastewater from homes and businesses in this quickly developing area get to a treatment plant that will clean it up. In the last episode, we saw the wet well be installed and the huge hole get backfilled. But there's still no sewer pipes yet. You might be familiar with how a wastewater pumping station works, but I bet you've never seen what one looks like from underground. Come follow along the progress and let me show you the most impressive parts of this project as it gets built.
I'm your host, Grady Hillhouse, and this is Practical Construction.
We're back at the San Antonio River Authority's newest wastewater lift station. We followed this project from bare earth to excavation to installation of the wet well and backfill. When it's finished, it will work together with its neighbor to move the area's wastewater uphill to the treatment plant. But right now, it's just a big concrete tank sitting in the ground. We still need to connect it to the sewage system. And the pipes that will make those connections possible were just delivered to the site. But they're not quite ready to install just yet. You might remember from the previous episode that this wet well was backfilled using a material called flowable fill. It's a mixture of sand, cement, and water that acts kind of like a low-strength concrete. And here's why. Even though this material has to be strong enough to avoid settling over time, it also has to be soft enough to be excavated with machinery so that the pipes can be installed. It might seem odd to backfill the area before installing pipes, but it's much simpler to excavate narrow trenches for the pipes afterward rather than try to keep those areas open during backfill of the rest of the site. 3 lines will connect this wet well to the surrounding sewer system, which means 3 trenches need to be cut out. These trenches will need people working inside them to install the pipes. If you've seen the previous episodes, you can probably guess what they'll be using to keep those workers safe from a collapse or cave-in. Shoring will be installed where the depth or stability of the hole necessitates. These steel boxes arriving at the site will brace the walls of the trenches. They get put in place with the excavator before anyone can enter the hole. Since sewer pipes are often buried well below the ground, especially at lift stations where they terminate at the bottom of a slope, they have to withstand considerable pressure from the weight of the soil above. To make sure the pipe can carry these loads, the design calls for select backfill around the envelope of the pipe. This gravel being delivered to the site will be used as the bedding material. It's called bedding because it conforms around the pipe to provide support. The bottom of each trench gets a layer of gravel bedding where the sewer pipes will eventually sit. But before the pipes go into the trenches, they need a way into the wet well. You may have noticed there are no holes in the tank just yet. That's because the location of the pipes is critical. They work by gravity, so it's essential that they be installed at the right elevation to slope into the wet well exactly as required in the design. If the holes came pre-installed, there's a chance that a subtle shift or twist of one of the segments would cause them to be misaligned. It's just easier to drill them in the exact right spot once the wet well is installed and backfilled in its final place. The pipeline crew takes their time to confirm the measurements with surveying equipment and double-check each of the connections. You know the old saying, measure twice, core through a foot of solid concrete once. This is the core drill that will be used to create the penetrations. First, a small hole is drilled into the wet well, and a concrete anchor is installed. This allows the frame of the core drill to be temporarily bolted to the wall to keep it in the correct location. The drill is assembled on the frame, and before long, it's running. It's basically an overgrown version of the hole saws that you might have used on wood or drywall. The core drill uses water from a hose to lubricate and cool the hole saw and keep the concrete dust down. The saw is advanced by hand slowly but surely through the concrete wall. Eventually, it breaks through on the inside of the wet well. All that's left is a heavy chunk of the concrete core. That's hole number 1 finished, 2 more to go. The drill is assembled in the next location and put to work. It's not long before the second hole is done. The third penetration goes just as smoothly as the previous 2, and by the end of the day, the wet well is ready to be plumbed in. The gravel bedding in the first trench gets its finishing touches to make sure it's at the right elevation and there are no protruding rocks that could damage the pipe. Then the line is lowered into the trench. To create a watertight joint between the pipe and the concrete wet well, a link seal is installed around its perimeter. This device uses rubber links surrounded by plastic to seal the annular space between pipe and concrete. Tightening the screws compresses the rubber material, creating a long-lasting, watertight connection. A second length of pipe is lowered into the trench to connect to the first one. These plastic sewer pipes attach together using a bell and spigot design. The spigot end slides into the bell, which has a gasket that provides a watertight seal. First, the spigot has to be lubricated so that it doesn't damage the gasket as it slides in. The 2 sections of pipe are pulled together using a chain hoist, and eventually the backfill will keep them from sliding apart over time. The first sewer line actually won't connect to anything at all, at least for the time being. As this area continues to develop, there will likely come a time when a third lift station is needed to deliver all the wastewater uphill to the nearby treatment plant. The San Antonio River Authority and their engineer knew how quickly this area would grow, so they made sure to proactively upsize this wet well compared to its neighbor. When more capacity is inevitably needed in a few years, all they have to do is install some new pumps instead of a completely new wet well. But eventually, Phase 3 will come, and this pipe will allow the new lift station to connect to the one under construction right now. Until then, this one gets capped off. The solid PVC cap is pulled into place at the end of the pipe, and it's almost ready to be buried. That's the first pipe in, and it's time to move on to number 2. Since this trench isn't as deep, it doesn't require shoring. Just like the first line, gravel is spread into the trench to act as bedding for the pipe. A laser level is used to make sure the slope of this pipe matches what's required in the plans. Once the bedding's in place, the pipe is swung into the trench. That big black bulge in the middle of the pipe is a flexible coupling. Although the wet well has been designed not to move, even slight shifts from settlement, temperature changes, or structural loads could put stress on the connected pipes buried in the ground. These flexible couplings give each sewer line some freedom to move independently of the wet well, like a gross bendy straw, reducing stress on the pipe and the chance of a break. It's covered in plastic to protect it from the backfill material. A second length of pipe is added to the line. Then, the whole string is bumped into position using the excavator. You can get a good look at that link seal here. Once it's connected to the wet well, the loader brings bucketfuls of bedding material and dumps them on top to hold everything in place until they're ready to backfill the rest of the site. This pipe will eventually tie into a manhole that will connect it to the rest of the sewer system, so we'll be back here in a minute. The third line running to the new wet well will connect it to the system of the existing pumping station already installed on this site. These two facilities will work together to move raw wastewater to the nearby treatment plant. This third line needs to pass under the concrete of the existing lift station, and that's going to require a saw. This crew has a walk-behind saw with a diamond blade that can cut through the slab like butter. It connects to the water supply to lubricate and cool the blade, and to minimize the amount of concrete dust in the air. They follow the lines marked by the surveyor, then they break the concrete up into sections to make them easier to remove. Once the concrete is up, the crew can trench the third line. As the trench is cut, bedding gravel is added to the bottom just like the other two. And the shoring is dropped in to protect workers from a cave-in before they can enter the trench. Thick steel plates are used on top of this concrete when the trench isn't actively being worked on to allow vehicles to drive over when needed and keep someone from accidentally falling in. Now that it's time to install the pipe, these plates get removed. The first pipe is lowered into the trench with the excavator. It's inserted into the last hole of the wet well, and then bedded down with gravel to hold the pipe in place. Once the plumbing is complete, the trench boxes can be removed. All three pipes get completely covered with the gravel bedding material that will provide even support. Since it's basically rock, the bedding material doesn't need to be compacted around the pipe, a process that might damage the plastic lines. Once the bedding is in place, shiny green warning tape is placed in the trenches. In the rare event that someone is excavating this area in the future, they should uncover the tape first to let them know there's an active sewer line not far below. Finally, the trenches get backfilled with soil to cover and protect the new sewer lines. Our old friend, the vibratory, remote-controlled trench roller, is back in action. It is kind of cute, but this roller compactor packs a strong punch, and it's the perfect size for working inside these trenches. A layer of backfill is added to the trench, and then it gets compacted into place. Every once in a while, a technician checks the density and moisture content of the backfill using a nuclear density gauge as a quality control measure. If the density were to be too low, the backfill would get another few passes from the compactor. Around the outside of the wet well, where a concrete slab will eventually sit, the engineer has specified that instead of compacted soil, the area be backfilled with flowable fill. Most of that fill was placed in the previous episode of the series, but now, where it was trenched out for the sewer lines, it needs to be placed again. The site is a little bit of a mess at the moment, so instead of trying to get the mixer truck around the entire wet well, the crew instead just uses the excavator bucket to get to the spots where the chute can't reach. Where it can, the flowable fill is placed right into the hole. Watching flowable fill go in is one of my favorite things. And the excavator bucket pats the backfill into place just for good measure. Just like that, this project's sewer lines are connected to the wet well and backfilled. Now it's time to connect them to the rest of the sewer system. The crew starts excavating for the manholes where the new pipes will connect to the existing system. But take a look at this. That's not a leak in the sewer line. It's groundwater traveling through the soil and right into the newly excavated area. From there, it's moving into the new sewer line and right into the wet well. You never know what you'll find when digging deep holes in the ground, but at least it's a good test that the new sewer line is working correctly. The crew installs a pump to keep the site dry while the new manholes go in. The first manhole will connect the new lift station to the sewer that runs into the existing facility. First, the concrete is removed and the area is excavated down. The excavator works carefully to avoid damaging the line below. Every once in a while, a worker checks for the pipe. Once it's exposed and visible, the rest of the excavation goes smoothly. The shoring is the last piece before the manhole can be installed. This is a doghouse manhole, named because of the U-shaped holes that allow it to fit over existing wastewater pipes. That line is in service right now, carrying sewage into the existing lift station, so it can't be disturbed. The manhole fits over the new line and the existing sewer. The crew lowers it into place and checks to make sure it's level. But the manhole doesn't have a bottom, yet. It'll have to be cast in place with concrete. Concrete forms called falsework installed by the crew plug up areas where the concrete shouldn't flow, keeping the inside of the manhole tidy while the outside can be a little lumpy. Concrete is dumped into the manhole and around the outside. An immersion vibrator is used to get the air bubbles out and mobilize the concrete past the sewer pipes. It's hard to see the work going on inside, but this concrete will be smoothed and shaped to create a gentle path for the wastewater to flow. Here's a peek into one of the other manholes on site so you can see what it will look like when completed. While one crew works on this manhole, another continues backfilling the trench. Each layer of backfill gets compacted into place with the remote-controlled trench roller. Manhole number 2 also connects the lift station to an existing wastewater line. The crew carefully excavates downward to the line to avoid hitting and breaking it. A worker with a shovel checks every so often until they find the pipe. Once the old line is exposed, they can excavate for the last segment of new pipe and the final manhole of the project. Both lines that connect to the new wet well also have a plug valve installed. This will allow the River Authority to divert wastewater to the other lift station when needed for repairs and maintenance. I'll show you how it all works once this manhole is installed. The last segment of pipe going to the new wet well gets lowered into place, measured, then cut to length. Finally, it's pushed into the bell to connect it to the rest of the line. Just like the previous one, this is a doghouse manhole that drops over the top of the sewer lines that it will connect. The crew works to install the falsework to hold back the concrete that will form the bottom of the manhole. You can also see the plug valve installed on the existing wastewater line. Once everything's ready, concrete is placed into the manhole and around the outsides to form the bottom. An immersion vibrator helps the concrete flow around the pipes. Again, this doesn't have to look pretty on the outside. It just has to form a stable bottom for the manhole and seal the areas around each of the sewer lines. Once the manhole bottoms are cured, each one gets a precast top segment that will eventually have an iron lid. And sealant tape is applied around the perimeter of each joint in the precast segments to prevent leaks. Those blue pipes hold the stems for the plug valves. Finally, the manhole bottoms and pipe segments get a leak test. Plugs are installed in the pipes where they terminate at the wet well. These get inflated to create a seal at the end of the line. Then each manhole is filled with water and left to make sure there are no leaks. Later, the pipes in the manholes will be cut so wastewater flows into each one, but for now, the pipes are left continuous so the manholes are bypassed during construction. Finally, I can show you how all this plumbing fits together. There's an existing wastewater line here that runs into this existing manhole. And there's another existing line that comes in from the opposite direction. Right now, they all flow into the wet well of the single existing lift station. But now, the San Antonio River Authority has options. The new line and manhole here, plus the two valves, means that all the wastewater from this line can be diverted into the new wet well. And the new line and manhole here means that all the wastewater from the other line can be diverted into the new wet well too. There's just one piece missing, and it just showed up in a truck. This monster plug valve is the last one needed to make these lift stations fully redundant. It will go on the 24-inch or 600-millimeter diameter sewer line flowing into the existing lift station on this site. But you can't just turn off a functioning sewer line to install a valve. All the houses connected to this pipe are still using it 24/7. So how do you do a job like this and keep the wastewater flowing? That process and much, much more on the next episode of Practical Construction.
We're past halfway in this series now, but if you can't wait to catch the next episode, it's already live on Nebula at the link below. Practical Construction is an experiment for me, something totally different than the typical videos I make. I've always wanted to do something like this, but spending a year on a construction site and shooting hours and hours of footage for a single 25-minute episode is kind of hard to justify. But I think you deserve to see how the constructed environment you depend on gets built around you, even if a 5-part series on sewage infrastructure isn't necessarily the best fit for the YouTube algorithm. That's why the series is best seen on Nebula. If you, like me, have given up on the TV networks but don't want to give up on high-quality educational content, Nebula's got you covered. And unlike TV, you'll never see an ad or interruption on Nebula. You've probably heard me talk about it before. It's a streaming platform built by and for independent creators. No industry executives or big production houses deciding what projects live or die, just people like me who are passionate about a topic they want to share with the world, or in my case, a massive sewage pumping station. And Nebula just keeps getting better and better. Totally ad-free videos from excellent educational channels, original series and specials that can't be found anywhere else, and even classes from your favorite creators like Adam Neely. I know there are a lot of streaming platforms out there right now, and no one wants another monthly cost to keep track of. But I also know that if you're watching a show like this to the end, there's a ton of other stuff on Nebula that you're going to enjoy as well. So I've made it dead simple. Click the link below and you'll get 40% off an annual plan. That means you pay just one time, $30 for an entire year's access to Nebula. That's less than $3 a month. Help me show the world how cool construction can be and get the best viewing experience on the internet while you're at it by clicking the link at the description below. Thank you for watching, and let me know what you think.